Hello. This video is going to be about reference angles and how we use reference angles to find the six trig functions. So I'm going to skip down here to the green, sorry, and just read through that. The green here is the actual definition of a reference angle. A reference angle is formed by the terminal side of an angle and the closest part of the x-axis. Sometimes theta is used to denote the given angle, and theta prime is used to denote that angle's reference angle. So the triangle that we form by using theta prime can be used to find the values of the six trig function values of theta. Now you can pause the video now and you can copy all this down, but it really will start making sense when we go through a couple examples. Okay, so here's our first example. We're going to look at the angle 120 degrees. And what we want to do is be able to find all six trig functions for this angle. The first thing I'm going to do is draw the angle. So 120 degrees is about right, oops, I'm not in drawing mode, hang on one sec. So if I draw 120 degrees, it puts me at about right here-ish. And what I have just drawn now is theta. So this is 120 degrees, and we'll call that angle theta. Well, there is no triangle there to find the sine of 120. Because to find the sine of 120, I need the opposite side of the triangle and the adjacent side, the hypotenuse. Well, there is not even a triangle there, or a right triangle there, when I just draw theta. So that's where the reference angle comes in. And the definition says a reference angle is formed by the terminal side of the angle, which is this one I just drew, and the closest part of the x-axis. So I'm going to draw straight down. Oops. I'm going to draw straight down to the x-axis. And now I have just found my reference angle. This right here, theta prime, that was very hard to read, sorry. So let's start this over here. This little angle right here is theta prime. So what we have just created here is a nice right triangle. But we have to figure that out. So theta prime is going to be 180 minus 120, or 60 degrees. So let's see here if I can get a different color. In other words, we're going to take 180 and then we'll subtract off this to get our angle here, theta. Once we have that, and we know that that is 60 degrees, and I'm going to come back down here now and kind of redraw this. We know this is 60, and our special right triangles that we had on that first page tells me that opposite 60 has a side of root 3, the hypotenuse is 2, and the side across from the 30 is 1. The only thing we have to be careful of is, since we're in the second quadrant, this x value here will be negative. So with this reference triangle, using our reference angle, I can find all six trig functions now. So the sine is going to be the opposite side over the hypotenuse. The cosine will be adjacent over hypotenuse. And the tangent is opposite over adjacent. And then the three other functions are going to be just the reciprocals. So this one will be 2 over root 3. This one will be -2, and this one will be -1 over root 3. The only thing left to do possibly now is to rationalize these So this one right here, if we times by root 3 over root 3, we will get an answer of, I'm running out of space here, so bear with me, we'll get 2 root 3 over 3. The secant of 120 is -2, so that's good. And the cotangent we need to rationalize by timesing top and bottom by root 3. And so we'll get negative root 3 over 3 for the cotangent. Okay, so here is another example. So we're going to look at the angle 225 degrees. And then we want to find the sine, well, all 6 trig functions again. So in order to do that, the first thing I'm going to do is draw the angle. So 225 is about right here. So here is my angle theta. It's a huge angle. Clearly is not a right triangle in any way. So what we're going to do is use the reference angle. And the reference angle tells you to take the terminal side and draw to the x-axis right here. And now we have ourselves a reference triangle that will help us find all 6 trig functions. So my angle here, theta prime, is the reference angle. To get that measurement, I'm going to take 225, subtract off 180, and I'm going to get 45. So theta is 45 degrees. According to our special right triangles, we have those sides in ratio of 1, 1, root 2. Now we're in quadrant 3, so the x has got to be negative, the y's got to be negative, and the hypotenuse is never negative. So with those 3 sides, if I can find all 6 trig functions. So the sine of 225 is going to be opposite over hypotenuse, or y over r. If I rationalize that, that's what I will get. So if you need to pause and multiply top and bottom by root 2 over 2 just to make sure you understand where that came from, please do that. Cosine is also the same. It's going to be adjacent over hypotenuse, or x over r, which rationalizes to negative root 2 over 2. And then tangent is y over x, or opposite over adjacent, which would be negative 1 over negative 1, or positive 1. When I go over to the cosecant, I'm going to flip this one so that I don't have to re-rationalize it. So I will just get negative root 2. Secant, I'll get negative root 2. And when I reciprocate 1 for cotangent, I'm left with 1. Okay, one last example. So we're going to do the same process, but now we have a 330 degree angle, and we want to find all 6 trig functions for that. So the first thing that we're going to do is get a picture of it. So the picture will be about right here. So this whole thing is 330 degrees. Again, we don't have a right triangle to work with there, so that's where the reference angle comes in. So from the terminal side, we'll draw to the x-axis, and now we have got theta prime. And we also have ourselves a reference triangle. So theta prime is going to be 360 minus 330, or it's going to be 30 degrees. All right, so we have our special right triangles. So we know if this is 30, across from the 30 is 1, The hypotenuse is 2. I'm going to get rid of this little mark here. And this side across from the 60 will be root 3. Now since we're in the fourth quadrant, the y value is negative, so that's going to be a -1 going down. Now that we have our reference triangle, we can find all 6 trig functions. So the sine is y over r. The cosine is x over r. And the tangent is y over x. The other 3 are just the reciprocals. And there you have it, using a reference angle and a reference triangle to find 6 trig functions for any angle.